Class, this is Dr. Selby here, and today I'm just going to solve two example pH problems. And before I get started, I just wanted to point out some key relationships for pH calculations, mathematical calculations. And this is something that you would be able to write down and keep on handy while you're solving these types of problems. In this first example, I'm looking for the hydroxide ion concentration, so that's OH minus in unit of molarity, of a solution that has a pH of 9.10. And so how am I going to start this? For me, it's easier to use this relationship first, pH plus POH equals 14.00. So I know the pH, and I'm going to solve for the pOH by subtracting pH from both sides, and that I get pOH equals 14.00 minus our pH of 9.10. And we can do that in our head or put it in our calculator. So we have 14 minus 9.1, and that equals 4.9. Okay, so now I know the pOH, and I can calculate the hydroxide ion concentration from the previous slide. This relationship here is that hydroxide ion concentration in unit molar equals 10 to the minus pOH. So that means in this problem equals 10 to the minus 4.9. So how do I enter that in the calculator? Well, I already have 4.9 in the calculator, and I'm just going to change the sign by using this plus or minus key here. So now we have minus 4.9, and now I want to use this here, 10 to the x button. So I'm going to hit the second function, and that gives me the 10 to the x function, and so we'll hit that. And this gives me the answer in standard notation. I want this in scientific notation. So I'm just going to hit the second button again, second, and go to scientific notation. And that gives me the answer in scientific notation. And the unit is molarity, and I'm supposed to round to two significant figures. So after the calculation, this equals 1.3 times 10 to the minus 5 molar OH minus. This calculator is free online, and you can just use this website if you would like to use the same calculator in your problems. Let's look at another example. In this problem, it says the hydroxide ion concentration of a solution is 3.6 times 10 to the minus 13, and that implies units molar. What is the pH? So for me, I think it's easier to find pOH and then find the pH. So how do I find pOH? So from our previous equation sheet on slide 1, we have pOH equals minus the log of the hydroxide ion concentration. And so that equals minus the log of 3.6 times 10 to the minus 13. And we're going to punch this in our calculator. So I'm going to enter in here 3.6, this EE button, and then I'm going to write negative 13, and then I'm going to take the log. And in standard notation, I'm just going to put this back to standard by second, this flow for floating point. So this equals minus a minus 12.4439 dot 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 dot. I'm just retaining a couple extra digits. And so that equals a positive 12.443, we'll say 37. Okay, so that's our pOH. but I need the pH. So next, I'm just going to use the relationship that pH plus pOH equals 14.00. And then I'm going to subtract the pOH from both sides to get pH. So pH equals 14.00 minus our pOH, and that equals 14.00 minus this 12.4437. And I just happen to have this number already in my calculator as a negative. I didn't change it in the calculator, I just changed it down here. So I could just take this and add 14. So plus 14 equals. And our answer, and we're supposed to round to the hundredths place, equals 1.56 after rounding. So that would be our final answer is 1.56. And that would be our final answer. So does that make sense? Well, if your hydroxide ion concentration is very low, then you would expect a high hydronium ion concentration and a very low pH. And so this answer does make sense. That's it for this micro lesson. Thank you and have a great day.